Hey mathletes, it's Mr. Noldy here. Thanks for tuning in. What we're going to talk about today are two-step equations. That's one of the most important algebra skills that you have. So let's break it down. So I have two equations already written up here, and these are some of the more simpler ones. And then I'll show you another round where they look a little bit trickier, but they really require the same two things. Those two things are you're going to add or subtract usually on both sides of an equation. And that way you isolate the variable term, and then you're going to take and divide, or if it's a fraction, multiply by reciprocal. But you're going to do the same thing on both sides of the equation. So let's look at this one first. So I have a 9x minus 7. So the first thing we want to do to isolate the variable term is add, actually let me do that in two colors. That would look really cool. So we're going to add 7 on each side. So add 7, are my colors showing up? So we're going to add 7 on each side of that equation. So what that's going to do is get rid of the 7 on this side of the equation, leaving just our 9x. And over here, well, negative 7 and positive 7, that adds up to 0. So this would be quite a dilemma for some students, but remember, if I want to undo this multiplication by 9. I want to isolate the variable. I don't want to know what 9x equals. I want to know what x equals. So what I would do is divide by 9. So forget that we have a 0 over here. That's all right. I can divide that by 9 as well. So what happens when we divide the left-hand side by 9? Those 9s cancel out, and we're left with what we're trying to figure out. What is x? And over here, just because it's a 0 doesn't mean we can't have 0 divided by 9. So 0 divided by 9, well, that's a 0. So x is equal to 0. So depending on where you're at in your math journey, you might have to go back up here and test that. If you're in Algebra 1 or Algebra 2, you might be good staying right here and just saying, okay, this is my solution. That seems reasonable. I could check it. 9 times 0 is 0 minus 7. So 9 times 0 is 0, so negative 7 equals negative 7. So that checks right off the bat. So the other one I would change or check is this one over here. So very similar pattern. You're looking for patterns. Mathematics is all about the recognition of patterns. So I want to isolate this variable term, this 8n. So I have to get rid of plus 7. So the opposite of plus 7 would be minus 7. So minus 7 minus 7. So that is the first step in this. And you'll get very good at these in short order. So what happens with the plus 7 and the minus 7? Well, they add off. That's what we wanted to have happen. That's going to leave us just with the 8n. My marker's not working so good. And what's 31 minus 7? Well, let's see. 31 minus 7, that's 24. Use a calculator if you need to. Don't be afraid to use a calculator. But now, I have the n term isolated, the variable term, but it's being multiplied by an 8. So how do you undo multiply by 8? Well, you divide by 8. So that is divide by 8 on both sides. So sometimes your instructors will have you show these steps that are in red. These steps in red we call transformations. Sometimes they'll just have you write all the equivalent equations. So remember, an equivalent equation has the same solution. So this n equals 3, with this equation n equals 3, and in this equation n equals 3. So those are equivalent equations, but in the pink here, that shows my transformations. So hopefully that was helpful for you. So pause 1 second, let us look at another round where you're going to have to do some multiplying on both sides instead of dividing on both sides. All right, thanks for waiting. Here we go with round 2. So notice these two equations, they have a variable divided by something. So instead of at the end dividing by the coefficient of the variable, we're going to be multiplying by what our variable is being divided by. So we'll start with this one over here. First thing we want to do again is isolate the variable term. So get rid of this 4. So subtract 4 on both sides of this equation. And I'll use my pink again here. So on the right hand side, what we wanted to have happen was those two go away. On the left-hand side, we have 0 minus 4. So that is a negative 4, and that equals n divided by 5. So now n is being divided by 5. So how do I undo, what do we do to undo division by 5? Well, the inverse operation of division is multiplication. So I'm going to multiply that by 5, but if I'm going to multiply the right-hand side by 5, I also have to multiply, make my n a little darker there, have to multiply the left-hand side by 5. So let's go ahead and do that. Multiply by 5. All right, now what happens over here on the right-hand side is we end up isolating the variable completely. Those 5s cancel out. 5 divided by 5 is 1, and 1 times n is n. So I have n. And 5 times negative 4, I almost said the answer, is a negative 20. Not digging this blue. Okay, so that would be our final answer. If I substituted negative 20 up here, negative 20 divided by 5 is negative 4. Negative 4 plus 4 is indeed 0. So that would be it for that one. Similar, over here, it looks like I have a fraction. It looks very complicated, but it's not. Because remember, what you want to do is isolate this variable term. So get rid of the minus 1 by doing its opposite. That would be a plus 1. So on the left-hand side, show that up more gooder. So those would add off, and then we have to do the same thing on both sides. That's the rule in mathematics, all the way until you get to, well, all the way forever, even through calculus. So negative 2 plus 1, that gives us a negative 1. So that was my first step. So now I have my variable m that I'm looking for, and it's being divided by 9. So how do I undo division by 9? Well, get my pink one again here. I'm going to multiply by 9. But I can't just multiply the left-hand side by 9. I also have to multiply the right-hand side by 9. So now all we have to do is cancel these 9s. 9 divided by 9 is 1, and 1 times m is m. And that equals negative 1 times 9, or negative 9. So your teacher may want you to double check those, but up here, if I went through and did negative 9 divided by 9, that would give me negative 1. Negative 1 minus another 1 is indeed negative 2. So that would work that way as well. So that is round 2. So stick around, we're going to do round 3, and it's going to be a little bit more complicated, but not too bad. There's still going to be two-step equations, so let's stick around for that. All right, so here we are back for round 3. Notice these look a little bit different, but believe it or not, they can both of them can be solved in 2 steps. So we'll start with the one over here on my right-hand side. So notice, to isolate this variable term, it's like a sum, an n plus 5 over top of negative 16. So I want to isolate the n plus 5. So how can I do that? Well, what we need to do is just multiply by negative 16. Because again, negative 16 divided by negative 16, that goes away and just becomes a 1. But you can't do this only on the left. We also have to multiply the left-hand side by a negative 16. All right, so let's go through and get our next equivalent equation. So negative 16 divided by negative 16 is 1. So the only thing remaining is n plus 5. And that is equal to negative 1 times negative 16 is positive 16. So last step is to isolate the n completely, is subtract. There's a plus 5 here, so we undo that with a minus 5. So subtract 5 on each side, like so. And notice what happens on our left-hand side. Those go away. And we're only left with n. N is the only thing that remains, and that's what it is we're trying to solve for. 16 minus 5, well, that becomes an 11. So n is equal to 11. So you could go back, substitute, and double check it, but that is how we got the solution of n equals 11. Here's another one that a lot of students might think that is going to take more than 2 steps. They might say, well, I have to distribute this 7. Then I would have to subtract 63 on both sides. And then, well, this doesn't have a variable with it, or a coefficient with it, so that's not really going to give us too much problem. But one of the easier ways, and this is sort of a ninja technique, a lot of people when they see it, students for the first time, they're like, oh, I didn't know I could do that. So I want to isolate the k plus 9, but k plus 9 is being multiplied by 7. So let's divide that by 7 and see what happens. Look at that. The 7's cancel, and you're just left with 9 plus k. Now, the gods are good here, so 84 divided by 7, that's just a 12. So that's my first step. That's one step. Sometimes these are fun. They're like a game, a puzzle to solve, and try to make sure you can do them in 2 steps. So k is what we want to know. I don't want to know k plus 9, so I have to get rid of the 9 here. So to get rid of 9, we subtract 9, because negative 9 is the opposite of positive 9. So what happens there? Well, those cancel out, and there's just the k remaining on the left-hand side. And what is 12 minus 9? Well, 12 minus 9 is 3. So that is k equals 3. So we showed you 3 varying levels of 2-step equations. So that's how you solve 2-step equations. They come in varying degrees, but I hope this helped. If it did, feel free to give it a like, share it with a classmate. But thanks for watching. I appreciate it, and I'll see you the next time.